After understanding the meaning of set in our previous video, we now move towards the different types of sets. First among the type of sets is empty set. A set which contains no elements. Or more specifically, a set having the property which can never be satisfied by any element declared. For example, set of all natural numbers between 1 and 2. As 1 and 2 are two consecutive natural numbers, so there is no possible natural number in between them. Although there are many rational and irrational numbers in between 1 and 2, but there is no natural number which satisfied above defined property. Hence set with such a property is empty set. Let us consider some other example of empty set. Set of all students presently studying in class 9th and 10th. Such set will be obviously empty set because a student cannot study in two classes at a time. Second example is set of even prime numbers greater than 2. This set is also empty set because there is only one even prime number, which is 2. So there can be no even prime number greater than 2. Third example is set of all rational solution of equation x square minus 2 is equal to 0. There are only two solutions of given equation, which are plus under root 2 and minus under root 2. Both these solutions are irrational. So there can be no element in such set. So this is an empty set. Empty set is also called null set or void set, and is represented by phi or bracket. Next type of set is singleton set. A set having only one element. For example, set of all whole numbers less than 1. This set is only with one element 0. Hence this is a singleton set. Let us consider some more examples. Set of all even prime numbers. As there is any one even prime number which is 2. So this set is singleton set. Set of solutions of equation x minus 5 equal to 0. This set is also singleton as only solution of this equation is 5. Third type of set is equal sets. Given two sets A and B are called equal sets. If every element of A is also an element of B and if every element of B is also an element of A, clearly, the two sets have exactly the same elements. For example, let A be the set of prime numbers less than 6 and P the set of prime factors of 30. Then A and P are equal, since 2, 3, and 5 are the only prime factors of 30 and also these are less than 6. Similarly, set A with elements is equal to set B with elements, which in turn is also equal to set C with elements, as repeated elements are counted and consider only once. Also, we have set x equals A, L, L, O, Y, and set y equals L, O, Y, A, L. Then x and y are equal sets as repetition and order of elements in a set do not change a set. Now let us move to our next type of set, which is equivalent set. Two sets having same numbers of elements whether their elements itself are same or different are called equivalent set. For example, set A equals 1, 2, 3, 4 is equivalent to set B equals A, B, C, D. Both these sets have equal numbers of elements. Next, a subset of set. A set A is said to be a subset of a set B if every element of A is also an element of B and is represented by symbol A is subset of B. For example, if X is set of all students of the class, and Y is set of all students of school, then X is subset of Y. Also every set is subset of itself, and empty set is always a subset of given any set. Because for given any set it is always possible to define a set which does not contains any element. For example, if A is set of natural numbers from 1 to 5, then set defined as all natural number between 1 and 2 is an empty set and also subset of set A. Although we could have defined empty set with some other property also, but still it will be considered as one empty set and will be counted only once while considering a subset of set. If A is a subset of B, then B is called superset of A and A is called proper subset of B if there is at least one element of B which is not in A. Next and very important type of set is power set. set of all possible subsets of a given set forms power set. Let us understand the concept of power set using an example. Let A be a set with 4 elements, A, B, C, D. P, A, be its power set. We will now, following the definition of power set, try to fill the set P, A. As we know that empty set is always a subset of every given set, so our first element of P, A is phi. Now all possible singleton sets will also be subsets of set A, hence next elements of P, A are. Now we will move to the combination to 2 elements out of 4 elements of A. These set being subset of A now become part of P, A. Now similarly we will include combination of 3 elements and 4 elements. This completely form power set of set A. Total number of its elements are 16. These are only possible elements of power set of A. No element other than these can be claimed as subset of A. Now my question is, do we always have to follow same long procedure to find the total numbers of subsets, or we can say total numbers of elements of power set? What if we are given a set of 10 elements? Then in such case the previous procedure will become too long, too time consuming and many times confusing also. In such situations we have one formula to find the total number of elements of power set when you have given numbers of elements of set. Which is, wherein as number of elements of set of whose total numbers of subsets or elements of power set we need to find. So for set having 10 elements, total numbers of elements in power set is 2 to the power 10. Next is universal set. Usually in a particular context, we have to deal with elements and subsets of basic set which is relevant to a particular context. For example, while studying the system of numbers we are interested in set of natural numbers and its subsets. Like set of all prime numbers and set of all even numbers and so forth. Such basic set is called universal set. Universal set is usually represented by U and its subset are represented by letter A, B, C and so on. For example, for set of integer. Set of rational number can be universal set. A even set of real number can also be universal set. Before moving towards our last topic, we must be clear with term cardinality of set. Total numbers of elements a set is having is called cardinal number, and is represented by this symbol or this symbol. For example, set of even natural numbers less than 10. This set has 5 elements. Now what about set of all even natural numbers? Can you count of the elements of this set? No. One can say cardinality of such set has no fixed value. A cardinal number is infinite. Means the set whose cardinality is finite is called finite set. For example, set of all prime numbers less than 20. This set is finite having 8 elements. And set whose cardinality is infinite set. For example, set of all real numbers, natural numbers, integers, rational and irrational numbers. Hopefully this video explaining different types of sets proved helpful to you. Thanks for watching. Thanks. For more maths related videos, do consider subscribing our channel. Math Shell. Thanks. For more maths related videos, do consider subscribing our channel. Math Shell.